Find the volume of the solid when the region bounded by y equals square root x and the x-axis is revolved around the line x equals 4. How about we stretch our artistic muscle a little bit, as we often have to do in Calculus 2. Now the square root of x function should look something like this. The x-axis is obviously the x-axis, and the line x equals 4, let's say, would be right about here. One of the most important things to do is to figure out the limits of our situation. We'd want to know about this point and this point and this point, since they obviously bound our diagram. This is obviously the origin, 0, 0. This point is going to be 4, 0. And this point would be the intersection of y equals the square root of x and the line x equals 4, which of course is 4, square root of 4, or 4, 2. So armed with this knowledge, let me make a little bit of room here and do the revolution part. Always the fun part. So to figure out the revolution, I imagine revolving this thing around this axis and kind of taking three-dimensional space with me as I go. That would create another half here. It's not too hard to prove that the point this would land on is 8, 0. And just to represent some of the dimension that this thing would have, I'll kind of put some lines in there. We have a dome shape. We have a nice dome shape going on. All right, so that's the solid we're talking about. And we're going to have to talk about the volume of said solid. To this end, I'm going to think about my dome as a stack of disks. I'm going to use the disk method, which is one of my favorite methods for this kind of problem. And there's an arbitrary disk that sort of encapsulates the properties of all of the disks we're going to talk about. I'm attempting to draw it right here. There we go. So this is my disk I'm going to use to represent a generalized disk. You can see they get fatter at the bottom, all the way to a radius of 0 at the top. And I like to begin my discussion of the volume of this shape by talking about the volume of one disk, this disk that I have drawn. This disk is cylindrical, and the volume of a cylinder is given by pi r squared h. In terms of the properties of this disk, we have a height, so to speak, measured along the y-axis, a distance we're going to call delta y. And we have a radius given by a certain distance, where this is an arbitrary location on the x-axis, and the distance between the center and that point, namely the radius of the disk, is going to be x minus 4. So we have a volume of a disk as being pi x minus 4 squared delta y. In a second, we're going to talk about adding all of the possible disks together to get a total volume, but before that, I need to address this issue here, the fact that the thickness is measured in terms of y, but another part, the radius, is talked about in terms of x. I will unify these two variables, choosing to go with the small delta thickness as the one that's going to govern which variable I use. I want to change this x into a y, which is pretty easy, because if y equals the square root of x, squaring both sides says that x is equal to y squared. So this is a valid substitution to make, that the volume of my disk is equal to pi y squared minus 4 squared delta y. Now it's time to talk about the volume of my disks, plural, which is a summation of the volume of a single disk. But the volume of specific disks, the volume of pi, y squared minus 4 squared delta y. In calculus, we like to write the integral from 0 to 2 of pi y squared minus 4 squared dy instead of delta y. The integral is fairly basic after factoring out pi and foiling out y squared minus 4 squared, which turns into y to the fourth power minus 8y squared plus 16 dy. Might as well perform the rest of the integral. It's going to be pi, integrating term by term. We'll have 1/5 y to the fifth minus 8/3 y to the thirds. This is the power rule for anti-differentiation, plus 16y, which must be evaluated from 0 to 2. The fundamental theorem of calculus says we must do this function with 2 subbed in for y, and then subtract the function with 0 subbed in, but with 0 subbed in, all of these terms, including this, would cancel out. So I'm just going to substitute 2, get pi times 1/5 2 to the fifth, minus 8/3 2 cubed, plus 16 times 2, which my calculator says is 53.61.